Welcome to the 24 Hours of Pass Summit Preview 2015. We're excited you could join us today for Margarita Naumova's session, The Top 8 Reasons for Your Transaction Performance Problems. This 24 Hours of Pass event consists of 24 hours consecutive live webcasts delivered by expert speakers from the Pass community. This session is a preview of one of the many technical sessions that will be presented at the Pass Summit in October this year. Recordings will be available in 1 week at 24hoursofpass.com. My name is Jens Vestergaard, and I work with BI engineering at Maersk Line. I've been working with BI and SQL Server for a decade in sum. I have a few quick introduction slides before I hand over the reins to Margarita Naumova. She will speak for 40 to 45 minutes, and then we'll move on to the Q&A, where you can ask her any question you may have. For the technical assistance, if you have any questions or if you are experiencing any issues, just type your question in the question pane in the GoToWebinar control panel and someone will assist you. Feel free to enter your questions in the Q&A field at any time. Once we get to the Q&A portion of the session, I'll read off your questions to the speaker. Since all attendees are muted, you will need to submit your questions by typing in the Q&A field. Also, there will be a short evaluation at the end of the session. Your feedback is very important to us, so please take a moment to complete it. It will appear in your web browser. Next slide, please. 24 hours of Pass would not be possible without the support of and dedication of our sponsors. They are the reason this event is available to you free of charge. I'd like to take a moment to thank our presenting sponsors, Microsoft, Dell Software, and Idera. And in addition, I'd like to thank supporting sponsors for this event, HP, SQL Sentry, and Pyram Analytics. Next slide, please. Next, I'd like to bring to your attention the upcoming Pass Summit. Taking place in Seattle, Washington from October 27th to the 30th, Pass Summit 2015 will feature over 200 sessions with world-class SQL Server experts. Planned and presented by the SQL Server community for the SQL Server community. Pass Summit is single-handedly the largest gathering of SQL Server and BI professionals in the world. With over 5,000 registrants from all over the world, Pass Summit is also a great place to network and meet face-to-face with experts, peers, and MVPs. More importantly, Pass Summit delivers providing you with the answers to your SQL Server issues, along with the knowledge, strategies, and skills you need to stay ahead of the curve. Save $200 right now by using the discount code 24HOP15 when you register. Optimize your saving by registering before the end of Sunday, September 28th. To find out more about the Pass Summit, visit passsummit.com. Next slide, please. Make sure you explore everything Pass has to offer for data professionals. You can join local user groups around the world, virtual chapters, find free online resources through our Learning Center, and read up on the latest community news in the Connector newsletter. For those interested in business analytics, check out the Pass Business Analytics Conference happening in May next year. Visit passbaconference.com for more information or to subscribe to our bi-weekly BA Insights newsletter. Next slide, please. This brings me to presenting Margarita Naumova. Maggie Naumova is SQL Server architect and consultant, speaker and trainer, Microsoft Certified Master of SQL Server 2008, SQL Server MVP, MCT, founder of SQL Master Academy, founder and leader of the Bulgarian SQL User Group. She has more than 15 years of SQL Server training and consulting experience, and Maggie is former member of the Microsoft Services Worldwide Technical Leadership Team, a Microsoft woman worth watching. Currently, she speaks, writes, and trains and consults people on SQL Server. And now, please allow me to present the speaker of the hour, Margarita Naumova.
Thank you, Jens. Hello, everyone. Thank you for joining me today in this session of top 8 reasons for your transaction performance problems. So my goal today will be to let you worry about your transactions, to force your attention on specific issues that your OLTP workload will probably have, and to give you a possible reasons for those issues. My goal at the summit will be to show you practical examples, demos, a lot of scenarios from the field where transactions are running slow, to explain the root cause and the reasons behind the problems, and to give you, of course, some hints for optimizations. But this will be not today, this will be at the summit. So thanks for Jens to this kind of presentation. I'm not going to add anything beside that I'm working in the field for a lot of years, and I'm doing about 50 projects on about performance tuning and optimization, and I can say that projects that has performance issues, all of them have something in common, and that's why I decided to go with this overview of some performance issues that are connecting to specifically to transactions. So why 8 exactly? I mean, well, I can define at least 80, but I stuck to 8 just because a lot of people do top 5, the other do top 10, so I got a number in the middle. And I'm trying to define the top 8 transaction performance issues because I really believe, according to my experience, that there are really differences between tuning the transaction approach and the approach that you have or you can have when you start tuning your OLTP workload. So based on that, and based on all the PTO projects in my career, I realized that I need to have an approach. So at some point, I realized that I really need an approach because it will help me to not miss something during my PTO projects, and it will help people isolate the root cause of performance tuning issues in a fast way. Because it's very often that you can find that the root cause differs from the issue that people complain of, and because all cases have something in common. So in my approach, I first start with a fast configuration checks, and I fix some configurations. There are a lot of common issues there and common mistakes that people do when configuring SQL Server. And the second one is just getting and analyzing weight and queues, getting deltas. And the third one is going deep into the workload and recording the workload, getting common events that the code generates, and isolate issues, intensity, statements, and batches. And based on that, I realized that there are really huge differences between the issues that the query-intensive type of workload has and the issues that the OLTP workload has. So beside those, beside this information that I got from the practice, there are a different type from the technical point of view. There are differences. So in order to explain you those differences, I'm using this popular diagram from the book of Brent Others. So if you explore a query travel through SQL Server components, then you will see that when you got a query plan and you got query plan saved in the plan cache and we start query execution, then we have to read from the data file and place the data page into the data cache. So only after that we can get the results and get some processing of the data page and read the data from it. So in this particular example, the query performance is critical, and some components depends on data files and the memory resources. But when you get a modification, then we have additional modules, additional components that are part of the transaction. So besides reading from data file and placing the data into the data cache and placing the execution plans into the plan cache, we have a very critical component as part of the transaction, and this is the transaction log. So when we modify the page into the buffer pool, we perform a synchronous modification into the transaction log. So the transaction log becomes very critical according to the performance of the transaction. So any delay in the transaction log as a recordings into the transaction log will immediately affect our transactions. So sometimes when you say that we have a blocking, then this is not just because the transaction is slow due to the code, but because the transaction log is slow on writes. So sometimes issues are not the first reason that you got when you run activity monitor, for example. So because of that, we can just list some critical resources that became a common points of common pain points in data modification issues. So there could be a memory and caches. So memory and caches, we need more memory, of course, for SQL Server, but it's not just adding more memory. It's just configuring memory and caches in a good manner and according to our workload requirements. The second one is, of course, disk issues and disk subsystem, and especially the transaction log. So the transaction log is really critical in our data modification performance. Of course, the code and the transaction itself could be a really important issue. So we can have a poor written transaction, we can have contention between transaction, but it's kind of a problem that could be as a second step in our identification problem plan. So first of all, we have to go through all those things as a configuration settings and memory and caches in order to isolate and optimize everything beside the code. So first, let me explore all those 8 reasons that I listed as my top 8 reasons. Of course, I'm not going deep into them, and I'm not going to do any demos right now. This will be at the summit part, but at least I will mention all of them, and in order for you to get your attention on all those issues. First of all, is a memory configuration is kind of my favorite because it's something that I usually got as a first impression in almost every case that I have at customer side. So I realized that in order to get a good performance, you have to have at least 2 memory settings configured properly for SQL Server instance. And first of all, you have to limit the SQL Server memory. So you have to have a max server memory configured properly. And the second one, in order to avoid the internal memory pressure, is to configure optimize for that to be true. So those 2 settings are really critical in order to avoid the external and the internal memory pressure on SQL Server plan cache, because those memory pressure events harm your SQL Server plan cache performance and your SQL Server plans, execution plans. So even it's more critical for queries, it's still valid when you have an OLTP workload. The second one, as a reason, is an overwhelmed I/O subsystem. Well, you say what an overwhelmed means. Actually, there are some attempts to define the overwhelmed disk subsystem, but at least you have to compare at least three counters in order to define that your disk subsystem is overwhelmed. First of all, you will have increased disk latency, which is average disk seconds per transfer. So you have to have between 5 and 10 milliseconds of disk latency on average. So especially for OLTP workload, where you have relatively small I/O disk sizes, disk I/O size. So in this case, when your system is slow, then you will face the increased write queue length and with kind of dependency of the disk I/O size. Well, I got a lot of examples of these kind of issues, and this example comes from performance analysis for logs tools, what I use in my performance tuning project. So this is an example of really overwhelmed disk subsystem. This comes from the real customer case. So you can see the average latency goes very high, and it becomes really an issue. So of course you cannot store your databases in a disk that is slower than a 3.5-inch floppy drive. So it's something that you have to pay attention on. But before replacing your disk subsystem, you need to go through a different analysis. So sometimes the reason is just not on the disk subsystem. Sometimes it could be just a shared workload working, or a bad configurations on your system, or something else. It just at the summit I will speak about the different examples of not just replacing the disk subsystem, but troubleshooting and finding the root cause of the problem. So one of the root causes could be a misconfiguring of the database and a huge amount of contention on the disk drives because of the poor layout of the database. So misconfiguration of the database means that you probably leave defaults for size and growth of the transaction log and the database file. So leaving the defaults lead to a high amount of growth events. So the growth event, especially it comes to the transaction log, is a synchronous event. So your transaction will need to stop, and the growth event will need to complete, and the transaction could continue just after that, which could be really harmful for your transaction performance. So during the summit session, I will show you an example that is really common for misconfiguration of the transaction log and how this affects a specific transaction of writing or inserting data into the database. So you will see how to isolate the file growth events, how to define if the file growth events is really harming your performance. So the file growth leads to fragmentation of the database and the transaction log, which is also something that you don't want to have in your SQL Server workload. Placing data on the log on the same volume could be something that you definitely heard about, but it's something that is underestimated. Especially when it comes to transaction performance, because the contention of writing to the log and writing to the database file could be really harmful for the right operations into the database. So ineffective combination of different write types, sequential vs random, could really harm you and lead to delays in your transaction log records. So last but not least, for a database performance and for database layout are those tempting settings that many people are trying to play with in order to optimize performance, but they could be really harmful. Auto close and auto shrink are kind of my favorite because they are like a magical bullet. When you just set them according to the recommendation, you can see immediately how the performance improves on your system. So please don't ever use auto close and auto shrink as to switch them on in order to optimize something. They could just harm your database. They could just decrease your transaction performance immediately. So statistics are really important, and even for transactions, they need to be up to date, and you have to have these maintenance procedures in order to update them regularly. So number 4 is something that is kind of a hidden issue. So this is something that is not very popular as a recommendation or as something that people can see, but it's something that also decrease your transaction performance a lot, and it is something that you can see as a huge amount of write log wait type appearing in your system. So when your transaction needs to create a record in the transaction log file, it first accumulates all the records into the log buffer area in memory, and only after the transaction fills this log buffer, which is sized as of 60 kilobytes, then the log buffer is flushing to the disk. And this is the first case when the transaction log records to the disk. So when it fills the log buffer, then it records the disk records the transaction into the transaction log. And this is kind of an optimal way of flushing the transaction log. So if your transaction is larger, then it will probably work in this way, which is, I would say, effective way of transferring data and working with a disk subsystem. But if your transaction is just very small, or if you have a huge amount of small transactions, then you hit the second case of flushing the log buffer into the disk, and this case is on a transaction completion. So if your transaction is small, then it has to flush the records on the disk when it completes, and in this way you have this log flush buffer very often performing on your transaction log files. So these are a huge amount of I operation in your transaction log. In this way, they could they could appear as a write log waits, because the buffer just wait for the log buffer to fill, and just only after that it will record into the transaction log the log buffer content. So it's not an effective way to write a transaction, and I will show you a lot of demos for that in my summit session. So due to this transaction pattern, you can face write log waits, you can face different issues, more IOs, you can face more flushes, and you can face also flush waits per second, which adds additional time to your transactions. So next one. Oh, this is a very good animation. I did it myself, right? Okay, so ineffective logging is my number 5, and particularly page split event. So page split is something which is also very common due to ineffective cluster index or improper cluster index. So during the summit session, I will go through the page split event, and I will show you the difference between a transaction with page split and without a page split, and you will see how the page split increases the duration of your transaction. So the page split is actually separating or splitting the pages on a leaf level of index because there is no space into the page and because you have to insert the record in this particular page. So the issue is actually due to not having a proper cluster index or a cluster index not on a good field, on a good column in your table. But the problem actually results in a new page allocation, in a copy records of the new page, in inserting the new records, in deleting the records from the former page. So all the steps for SQL Server to perform a page split are part of your transaction log records or a part of your transaction. So this is something that SQL Server has to do and has to log into the transaction log. So it will definitely increase your transaction log and increase the records into the transaction log. As a result of that, it will increase the transaction duration. So ineffective logging is something that is very common as an issue into the transaction space. So over-indexing is a number 6, which is having more indexes than it's optimal for performing a transaction, and that's because every index potentially adds a new record in your transaction log. And this is especially true for delete operations. So if you have to delete a record into your table and you have a non-cluster index, then you potentially have to have a delete, have to perform a delete on your cluster index and have to delete additional record from your non-cluster index. So you perform more operations on the data level into the data pages, you read more data pages into memory, and you, as a result of that, you write more pages or more data, more log records into your transaction log. So you can have a very slow delete when you add when you have more non-cluster index in your table. So this is a factor for transaction performance also. So we need to pay attention on all those non-cluster indexes in order to be sure that we optimize our transaction performance. So the next one is latch contention. So it's a contention on latches, which means is a page concurrency, not an I/O issue. Is a concurrency on a same page, and transaction has to wait due to this kind of concurrency. So there are a lot of reasons for this that you could find into your workload. If you do a detailed analysis that I'm going to show you during the summit, then you can see that the page latch contention is due to either TempDB misconfiguration. This is kind of a common case. So when you have a TempDB misconfiguration and if you use in your code or as part of your transaction temp tables or table variables, then those working with those temp objects will be very slow. So you can face a page latch contention on those PFS or CAM or SCAM pages on TempDB, or the other case could be index hotspot or index page hotspot on inserts. So for example, when you have in a cluster index on an identity column, then, and you have a lot of sessions that are doing an insert at the same page, then they will probably face a contention or a latches on this last page or same page of the index. So this is kind of a common also, and there are different scenarios of troubleshooting this case that I'm going to talk about during the summit. But I got this example, one example at the customer side, when they had a very very bad issues. They have very bad performance problems, and they were thinking about the code and the page latch contention and the code issues. And they blamed the application about that. But when I did a performance tuning and when I analyzed the error logs and the everything as a configuration on the first point, then I realized that they have a very bad disk subsystem response time. So they had about 300 virtual machines running on the same storage where the databases and the transaction log were. So after detailed analysis, I found all those issues for the transactions that I'm talking about. They had latches, they had blocking, they had everything, but all these issues were because of just slow disk response time. When we tried to test a different disk storage, then they still had those issues, but according to their service level agreements, those issues were not so critical for them. So they had time to overcome or to plan for troubleshooting all those code type issues and schema type issues. So they had this temp table creation template and this index on table in the same batch. You probably know that we have this template fixed in SQL Server 2014, but they were working with a previous version of SQL Server. So you can still have those issues, and I'm not saying that every one of those is a root cause. You have to find, the challenge is to find the root cause of those issues. So which one of those is the primary reason for your transaction delays? So any of them could be a primary reason for that. So the last one is blocking, and it's not kind of a I'm not putting it on the first place, I'm not putting the blocking on the first place because it's usually accepted as a common reason for transaction delays, but it's not like that on every case. So you can face blocking, you can see the blocking when you see the wait statistics or waiting sessions or even activity monitor, but you have to go deep into the problem in order to find out what is the main issue, what is the main reason of blocking. So according to my experience, I got at least 70% of all those blocking cases because with the root cause that are different than just holding the lock or just coding in a wrong way. All those 70% were because of some resource blocking or waiting for a resource, or for example waiting for a disk, or waiting, just increasing the duration of the transaction because of page latch waits, or because of write lock waits, or because of memory issues or CMEM thread waits. So you have to define, and this is the challenge of every performance tuning project, defining the root cause of the problem. Because if you just rewrite a transaction or just create an index, and in order to troubleshoot the specific issue, it's very likely to observe this issue after some time if you haven't managed to isolate the root cause. So just coding in a wrong way, for example, opening the transaction and going with performing deletes with a cursor is not very common. So thanks God, of course, it's not very common. But most common reasons are outside the code, and you have to fix them first, because it's easier to fix them instead of just rewriting the code. So it's something that we have to face, we have to check first in order to say something like the code is wrong or the code is not according to the good practice at all. So beside that, I realized that it's extremely hard to optimize both complex queries workloads and transaction workloads. So I face these transaction performance issues very often when I have these mixed kind of workloads. So beside that, I realized that the major reason of transactions delays are usually connected with the transaction log. So you have to start searching the reason into the transaction log, but not focusing only on the transaction log. It's good to start with all those configuration checks first, like memory configuration, like configuration of the CPUs of SQL Server, all those processors, cost thresholds and everything. And check the options on the database level, check your transaction log configurations, absolutely avoid log growths during the workload. So it's equally important to fix all those things, and it's easier to fix them before blaming the code. Of course, I'm not saying that the transaction delays are not due to the code written in a not good manner, but there are some things that you can do before changing the code, and you will probably see a different percentage of optimization, and you can plan and you can isolate the code problems easily after that, and you can plan for fixing all those code issues. So during the summit, I will show you not just demos, but I'm going to show you examples from my performance tuning assessment projects and performance tuning assessment reports. So I'm in the process of sanitizing them in order to be able to show them to you, and you will see the examples from the real field and from the field, and you will see my way of doing this performance tuning optimization steps and isolating the issues. So of course I realized that these top 8 performance issues are not enough. I mean, I can speak a lot about performance issues, and as I told you, I can list at least 80, not 8, but I have just 1 hour, and I will try to just point to those top 8 that I face a lot in almost every, I would say, in almost every performance tuning projects that I got in the last 8 years, last 8 to 10, I don't remember, but and there is really a difference between troubleshooting the query type of workload and the transaction workload type. When you go through all those steps, you'll see that you can gain a lot of benefits just because of following the steps and checking the configuration, checking the weights, checking and analyzing and trying to find the root cause of the performance issues. So I'm not going to speak in more details right in this session. So that was my top 8, and that the details are will be part of my past summit transaction. So I will. That's all for me for today, and I'm expecting your questions right now.
Okay, yes, so far we only have one question in, so while we do that, please type in your questions in the chat or question box in your webinar panel. If we have no other questions, then I have some. But the first question is from Roy Gavish, and he asks, or she asks, would you suggest to always enable the optimize for ad hoc workloads option? And maybe more importantly, when wouldn't you enable it?
Yes, that's a very common question. Thank you. I will always enable optimize for ad hoc. That's something that I always do, just because I think that I'm not facing any drawbacks. So I'm wondering why it's not default, but it's another topic. So I always check this because I realize that I have a lot of workloads with an ad hoc type of workload. So you got a huge pressure on the caches just because you send a lot of ad hoc queries. And because of that, by default, ad hoc queries are not going to be reused as a plan. So it's kind of a wasted space into the plan cache. So in order to avoid blowing the plan cache, I will just set this to true. And as a result of that, my ad hoc plans will consume about 300 bytes in the cache instead of, for example, 24 kilobytes. And as a result of that, it will be, you reduce the chances for your SQL cache to go in a very, very large size. So I will definitely define this as true for every SQL server, no matter if this is a production server or this is something like testing or dev environment. Just this is something that it's a must for me. So this is the first thing that you have to do in order to optimize the plan cache usage for and avoid the internal memory pressure that it's coming from the plan cache store, which is holding the ad hoc plans. You can hit another threshold as number of plans in cache because they become smaller in size, so you can save more plans in cache. But it's another story. So there are troubleshooting steps when you hit this second threshold also. Did I answer your question?
Yes, yeah. I believe so.
Okay.
So we have another one from Barry O'Neill. If the database files are on a shared SAN, is it still preferable or practical to have the log and data files on separate disks, LUNs?
Yes, absolutely. So this is practical and preferable to separate them, still separate them. If you think about fragmentation of the LUN, if you think about the risk of growing the file and filling up the space, and still, by the way, you can check, I think Paul Randall has performed some benchmarks and has published on his website, SQLskills.com, benchmarks of testing different scenarios of separating or not the files on the same LUN, the database files and the transaction logs. So you can check the numbers there, and you can check this, and you can ensure that it's still preferable to do that, especially if you have if you can have a deal with your storage administrators, because this is the difficult part of the job, I think.
Okay, next one is Rick Todd, who asks, what would lead to lots of CX packet weights? And I guess this one could be, it depends, but let's hear it from the expert.
Of course, it depends, but I think actually this is kind of a common topic, a very popular one. So my experience shows that if you just have a CX packet weight, it's not it doesn't mean that you have a problem in your workload. So it just means that you have a parallel execution plans running in place. So TechX packet means that your threads are waiting for one another to complete when your query is executing in parallel with a parallel execution plan. So it doesn't mean it's just a fact. It doesn't mean that you have a performance problems, but if your TechX packets weights is something that limits the throughput of your queries or your transactions, or it's something that leads to weights, to additional weights, or to limiting the throughput of the overall workload, or you have the TechX packet weight total amount of time or total duration of TechX packet weight, it is more than 10 to 15% of all weights duration in your instance, then you probably have problems with this parallel query execution or parallel plans. So in this case, you probably have ineffective plans, ineffective parallel plans that are running on your instance, on your database. So probably some queries are more effective to run serially rather than to run in parallel. And in this case, you can optimize that by playing with max degree of parallelism and with a cost threshold of parallelism. So playing with both settings is something that you need to do. It's not just reducing the max stop. Don't do that. It's something that will harm the overall SQL Server performance. So on an instance level, you should be very careful when setting those settings. My experience, what I'm doing on the customer side is, for example, I'm setting the cost threshold of parallelism to a higher value. 5 is absolutely not enough. So it should be about, for example, I'm starting with 40 or 50. So I'm setting cost threshold parallelism for 40 or 50 in order to set the limit for the parallel plans. I mean, you just increase this threshold because you want only complex queries to go and run in parallel, because potentially they will have the optimal execution for parallel plans. Relatively simple queries with a low cost, they have to go, and they will probably be more effective when they execute with their serial plan. So cost threshold of parallelism does just this. And the next one, max degree of parallelism, there is a KB. You can read the KB article of how to configure the max stop. So you can configure the proper value of the max stop, but the important thing to go is just not just going with the max stop, but with configuring both settings in order to have the optimal TechX packet weight, or to avoid the TechX packet weight to become an issue on your workload. That was my answer.
Okay, we have one final question. If you maybe briefly could.
Sure. I will try to do it briefly. Okay.
In which cases is it recommended actually to modify the max stop value?
Well, you have to know your workload, by the way. So if you have your if your workload contains of a mixed workload as a complex transactions, complex queries with the transactions, then this is a typical scenario when you need to configure the maxed-up, or you need to change the default maxed-up. In this way, if you probably, in this kind of a complex scenario, you will face this TX packet weight as a limiting throughput or as an issue. So in these scenarios, with the mixed workloads, you have to consider to tune the maxed-up on a SQL Server level, but please align with the KB. So don't make it too low, never make it 1 or something like that. And you can, if you find some query that is running slow or faces a huge amount of TX packet weight, then you can do a maxed up per query, I mean as an option hint or as a plan guide or something like that. So this is the next step to go.
Okay, I think we can squeeze in the last question.
Okay.
Does AutoShrink actually run DBCC shrink file, and is there ever a scenario where it would be beneficial?
Never. I mean, it will never be beneficial. AutoShrink is a new for me. So it's something that goes through the database. It performs DBCC shrink database, not shrink file, and it's just performs a huge amount of I operation. It reads a lot of pages. It brings them to memory. It writes them again to a different place on disk, and it just purge your memory, your buffers. It performs a lot of I operations, and beside that, everything is fully locked. So if you still have doubts about AutoShrink or about DBCC shrink database, then you can go to my blog and you can see my blog post, what is inside the DBCC shrink and DBCC shrink database. So I'm explaining the methodology of the shrink database and how it harms your database performance. So never do that.
Okay, so that was the final question. I guess we move on to the next slide.
Okay. Oh, sorry.
So, like what you've heard, Margarita will be presenting at PASS Summit 2015. The general sessions will be the top 8 reasons for your transaction performance problems. You can contact her on LinkedIn and read her blog. And please use the discount code 24HOP15 to save $200 when registering. Thank you for attending the top 8 reasons for transaction performance problems. I'd like to thank Margarita for her time and her expertise. Again, I'd also like to thank our presenting sponsors, Microsoft, Idera, and Dell Software, and our supporting sponsors, Pyramid Analytics, SQL Sentry, and HP. I hope you enjoyed this session as much as I did. Follow along on social media with @PASS24HOP and share your thoughts on the event with hashtag PASS24HOP and hashtag SQLPass. Stay tuned for our next session, building a scalable analytics solution using IIS and Elasticsearch with Alan Mitchell. It's going to happen in a few minutes. Thank you.